Hello, ELT 132. This is Roger Young, and this is part 2 of the series on counters, the video series on counters. Now, as I finished up the last video, I said we're going to talk about a circuit, right? A counter circuit. Well, look at what we have. This here is a counter circuit, all right? Here are your outputs, Q0, Q1, Q2. It uses 3 JK flip-flops, 1, 2, and 3. It has a common clock for each flip-flop. You see this? 1, 2, 3. So all their clocks are connected together. Now, when you're given a counter like this, the trick is you need to determine the equations for the J and K inputs for each of those flip-flops. That's what we're going to do here. Then once you have the equations for the J and K flip-flops, then you can fill out your state table, and that's what we're going to do here. The first time through it may seem a little bit confusing, but the more you do it, the easier it's going to get. So why don't we just start and get going here. So the first thing I want to do when I do this is label the least significant and most significant flip-flops. So you can see that we have an output here, and this is Q0, right? If you follow this all the way back, I'm working backwards here, right? Yeah, look, right here, it goes to this flip-flop. So I know that this is 0, right? If I look at Q2, come up here, look at it. I know that this is 2, isn't it? Nice space there. Now look, you don't have to do this when you're doing your homework. This is something that I do because I always want to make sure I go back to the right flip-flop and keep it straight. So now, let's try to figure out these JK equations. And let's just start at the least significant bit, okay? So if you look at the least significant bit, that's Q0, right? Which is this flip-flop here. You're going to see that K is connected to VCC. So hence K is always going to equal 1. And the J goes through an inverter. You see how I'm going backwards here? I'm starting, this is an input. Usually you go into it, but to figure it out, we have to actually go backwards, right? So we have a J, we're going into an inverter, right? And then if we follow this inverter all the way along here, it comes out of Q2. So this is, see, here's your 2, right? So this is Q2 bar. So J is Q2 with a bar over it, and K is 1. So let's go over here to 0. K0 is 1, J0 is Q2 with a bar over it. All right, we got that one. Let's try the middle one here. So for the middle one, which is Q1, our J and our K are connected together. You see that? So they're going to have the same value, or the same equation and same value, and they're both connected to what? Here's the output of Q, and it's the least significant. So this is Q0. So the output Q0 is connected to J and K. So if we come down here, J1 is equal to Q0 and K1 is equal to Q0. Yeah, that makes sense, right, for our circuit. Finally, let's look at this one over here. Well, K is connected to VCC, which means it's 1, obviously. And J, well, J is connected to the output of an AND gate. And there's 2 inputs there, right? One input comes from Q0, right? The other input comes from Q1. So if we come down here to our equations, we see that K2 is 1, which makes sense. And J2, which is this right here, is Q1 ANDed with Q0, which is what we see here. This is Q0, this is Q1, and they're both ANDed together and connected to J. So J2. So here are your equations. Notice that your equations are all in terms of Q0, Q1, and Q2. All right, that's very important because that's what we're going to use to fill out our state table. So now, once we have these equations, the next step is to start filling out our table. What the table does is when you start, I'm going to put a little arrow here, all right? This is where we're starting from, right here. So when we're starting right here, we need to know after a clock pulse what the next state is going to be. That's the entire reason for this. So we do that by using these equations for each one of these flip-flops, right? So once we use these equations to determine the J and K inputs for the flip-flops and its clock, we will then know what the state is for each one of those Q outputs, right? All right, so let's try this one. Let's look at, what are we going to do first? Well, let's start from left to right, okay? So we're starting here with 0, 0, 0, J2 and K2. What's J2 equal? We come up here, J2 is equal to Q1 ANDed with Q0. Well, Q0 is equal to 0. I'm sorry, Q1 ANDed with Q0. I shouldn't say Q0, that can get confusing. So Q0 is equal to 0. Q1 is equal to 0. If you AND them together, you're going to have 0. So this is why your J2 is equal to 0. K2 is equal to 1 because it's tied to VCC. That's never going to change, right? So if you recall, when you clock a JK flip-flop with J equal to 0, K equal to 1, that's known as reset. And your Q output is going to be low. Okay? Next, if we look at J1 and K1, right? Well, J1, K1, they're both tied to Q0, right? So if we come back here, what's Q0? Q0 is 0. So both J1 and K1 are 0. And if you recall, if neither J or K are high or active, then the output will not change. So that's known as the no change state, or no change. So I don't think it's a state, but it's no change. And you can see up here from the truth table for a JK flip-flop, no change, right? Finally, J0, K0. We look, K0 is always equal to 1. We know that. J0 is equal to Q2 with a bar over it, so it's Q2 not. So if we come back over here, Q2 is 0. Well, we're going to have to invert it, so it's going to be a 1. And that's where you get your J0 value. And a 1 and a 1 on your JK inputs to a flip-flop indicate a toggle. All right? So now we have these figured out. So let's go back. J0, J2, K2. If we clock it, J2, K2. If we clock it with J2 equals 0, K2 equal 1, we clock it, that's going to be a reset. So we know the output for that is going to be a 0. Q will be 0, right? J1, K1, it means it's no change. So we have to go back and find out what Q1 is now. It's 0, it's 0 presently, so it's going to stay 0 after the clock, right? Finally, we have J0 and K0 here. And if we have this in the toggle state, which it is, it's going to change the value that was there. So if we look at Q0, that's equal to 0. Q0 has a 0 output. And if we're going to toggle it, it's going to become a 1. So this is your next state. Now, if we take this next state right here, right? If you notice, let me just make sure we can do this here. Right here, this next state now becomes the present state of your subsequent row. Okay? So now you're going to start here. And you're going to go through the exact same exercise we just went through, right? You need to find out what J2 is, for example. J2 is Q1.Q0. Well, Q1.Q0 is still going to be 0, because remember, they both have to be 1. They're ANDed, right? When I say Q1.Q0, I meant Q1 ANDed with Q0, by the way. So that's going to stay 0. And this value is going to stay 1 because it's tied to VCC. So we know that, and that's reset. J1 and K1, right? That's equal to Q0, right? Well, if we come over here, what's Q0 equal to? Q0 is equal to 1. Hence, these are 1, 1. So that's the toggle state, right? Toggle condition, I should say. And finally, let's look at J0, K0. That K0 is going to stay 1. It's tied to ground, or tied to VCC, I'm sorry. J0 is equal to Q2 bar. Well, what's Q2 equal to? 0. Q2 bar then would be equal to 1, right? Hence you have 1. So with 2 1s, this is in the toggle condition, just like J1, K1, and this is in the reset condition. So let's just go through and fill out the next state, right? For J2 and K2, right, that's reset, so we know that's going to be Q2 equals 0. Bingo, we got it. J1, K1, well, that's going to be a toggle condition. If we come back here, we see that presently that Q1 flip-flop that has a 0 output, you toggle it, it's going to become a 1. And your J0, K0 output, that's going to toggle. Presently, it's a 1 in the present state, so that is to toggle back to a 0. And then here is your subsequent next state right there. And then this value will come down here. You're going to go through the same arguments again. This value will come down right below it. You're going to go through the same methodology again. And you're going to have this one right here. It's going to come up right here, I'm sorry. And then finally you're going to end up with 0, 0, 0. And what did we start with? We started with 0, 0, 0. So it's just going to repeat. So this counter will count up. And it will start at 0. It will go to 1, 2, 3, 4, and then back to 0 again. All right? So this is an up counter. And if we wanted to write it, we could write, this is not very good. I'm drawing it here. Here's your state diagram. What would it be? This one would be 0, 1, 0. This one would be, all right, and this one would be 1, 0, 0, and then this one would be back to, this is supposed to be 0, 0, 0. My handwriting, please excuse the handwriting, I'm not very good at this, but you get the idea. Here's your state diagram. This is your state diagram, right? This kind of gives you a visual about the counter. This is your table, your state table. This shows you how it progresses through here. Obviously, this is your circuit. I hope this has been helpful to you, and thank you for watching.